The experiment requires a set of basic materials for a chemical reaction demonstration. A common household balloon will be used to capture a gas. Vinegar, typically a 5% solution of acetic acid, is a key reactant. Baking soda, or sodium bicarbonate, will react with the vinegar. An empty bottle is needed to contain the reaction. These materials will demonstrate a simple acid-base reaction, producing carbon dioxide. Begin by acquiring an empty bottle to serve as the reaction vessel. Carefully pour vinegar into the empty bottle. Ensure the amount of vinegar added is clearly visible for accurate replication of the experiment. The quantity of vinegar is a key variable affecting the reaction's outcome. Proper measurement ensures consistent and repeatable results. The initial step involves preparing baking soda for an experiment. Carefully measure the required amount of baking soda. A balloon will serve as a container for the baking soda. Hold the balloon's opening wide to facilitate the transfer. Slowly introduce the baking soda into the balloon, avoiding spillage. Ensure all the baking soda is successfully transferred into the balloon. The initial step involves carefully affixing a balloon to the opening of a bottle. It is crucial to create an airtight seal between the balloon and the bottle. This seal prevents the escape of any gases from the bottle into the surrounding environment. The connection point requires particular attention to ensure a secure and leak-proof bond. Proper attachment is essential for subsequent steps or experiments involving gas containment. The experiment involves mixing baking soda and vinegar to initiate a chemical reaction. Baking soda is carefully dropped into a container of vinegar. The combination of these two substances triggers a chemical process. This process results in a chemical reaction. The reaction produces observable effects. A balloon is inflated using carbon dioxide gas. The carbon dioxide is produced by a chemical reaction. The reaction involves baking soda and vinegar. Mixing baking soda and vinegar generates carbon dioxide. The generated carbon dioxide fills the balloon, causing it to inflate. Mixing baking soda, a base, with vinegar, an acid, initiates a chemical reaction. This reaction produces carbon dioxide, CO2, gas as one of its primary products. The generated carbon dioxide gas expands, seeking to occupy a larger volume. When contained within a balloon, the expanding CO2 inflates the balloon. The mini volcano experiment requires a few common household materials. Key ingredients include baking soda, which acts as a base. Vinegar, an acid, is also essential for the eruption. Food coloring can be added to enhance the visual effect of the lava. Begin the volcano model construction by placing a small cup or bottle on a stable surface. This cup or bottle will form the central cone of the volcano. Carefully add baking soda into the cup or bottle. The baking soda will act as the primary reactant for the eruption. Ensure there is enough baking soda to create a visible eruption effect. Food coloring is added to the baking soda in the cup. The food coloring is used to enhance the eruption's visual effect. The coloring will make the eruption more vibrant. Different colors can be used for varying effects. The added color does not affect the chemical reaction. The color only serves to improve the visual appeal. The simulation begins with a cup containing baking soda and food coloring. Vinegar is slowly poured into the cup. The vinegar reacts with the baking soda. This reaction produces carbon dioxide gas. The increasing pressure from the gas causes an eruption. The food coloring enhances the visual effect of the eruption. A chemical reaction is initiated to simulate a volcanic eruption. The reaction produces gas within the mixture. The generated gas increases pressure, forcing the liquid mixture upwards. This expulsion mimics a lava explosion from a volcano. The combination of baking soda and vinegar initiates a chemical reaction. This reaction produces carbon dioxide gas as one of its primary byproducts. The generated gas increases the pressure within the confined space. This pressure forces the colored liquid upwards through any available opening. The expulsion of liquid resembles a volcanic eruption due to the pressure release. Therefore, the reaction effectively simulates a miniature volcanic event. The walking water experiment requires a few simple materials. 3 cups are needed to hold the water. Water is the primary liquid for the experiment. Food coloring is used to differentiate and visualize the water movement. Paper towels act as the medium through which the water travels between cups. Begin by gathering 3 identical cups. Fill 2 of the cups with equal amounts of water. Add a different color of food coloring to each of the filled cups. Stir each cup until the food coloring is fully dissolved, creating 2 distinct colored solutions. Leave the 3rd cup empty, positioning it between the 2 colored water solutions. Paper towels are used to connect filled cups to an empty cup. Position paper towels between the cups. Ensure the paper towels bridge the space between the filled cups and the empty middle cup. The paper towels will act as a medium for water transfer. This setup allows the water to move from the full cups to the empty one via capillary action. Capillary action is the ability of a liquid to flow in narrow spaces without the assistance of, or even in opposition to, external forces like gravity. This demonstration uses colored water to visually track the movement of the liquid. Paper towels act as the narrow spaces through which the water travels. The water moves against gravity, climbing up the paper towel and into the empty cup. This movement illustrates the principles of capillary action in a simple, observable way. Water walks from filled cups to an empty cup using paper towels. This demonstrates capillary action, where water moves upward against gravity. Paper towels act as a medium through which water molecules are attracted. This attraction overcomes gravity, pulling water from higher to lower levels. Capillary action is the movement of a liquid through narrow spaces. This movement occurs without the assistance of external forces like gravity. The action is driven by intermolecular forces between the liquid and the surrounding solid surfaces. In paper towels, water moves through tiny spaces due to capillary action. This phenomenon allows paper towels to absorb liquids effectively. The magic balloon experiment demonstrates a chemical reaction that produces gas. The reaction involves mixing baking soda and vinegar in a closed container. This combination generates carbon dioxide, CO2, as a byproduct. The produced carbon dioxide gas inflates the balloon, showcasing the gas production. The mini volcano experiment simulates a volcanic eruption on a small scale. The reaction between baking soda and vinegar is the core of this experiment. Mixing these two substances produces carbon dioxide gas. The generated gas creates pressure inside the volcano model. This pressure eventually forces the mixture out, mimicking a volcanic eruption. The walking water experiment demonstrates capillary action. Capillary action allows water to move through the paper towels. Water molecules are attracted to the paper towel fibers. This attraction pulls the water upwards against gravity. The process continues until water levels in connected cups equalize. The experiments demonstrate scientific principles using simple materials. Each experiment highlights different aspects of scientific concepts. The comparison reveals the diversity of scientific exploration. Simple materials are used to illustrate complex scientific ideas. The experiments are designed for easy understanding and replication. Contrasting the experiments showcases the breadth of scientific inquiry. The scientific method begins with observation, where phenomena are carefully noted and described. Based on observations, a hypothesis is formulated as a testable explanation or prediction. Experimentation involves designing and conducting controlled tests to gather empirical data. Data collected during experiments is analyzed to determine if it supports or refutes the hypothesis. Finally, a conclusion is drawn based on the experimental results, either confirming or rejecting the initial hypothesis. Prioritize safety when conducting science experiments at home. Adult supervision is essential for all home science activities. Ensure proper handling and storage of all experimental materials. Review all safety precautions before starting any experiment.